Assalamualaikum warahmatullahi wabarakatuh and hi everyone. This is the second part to this topic of momentum. In the first part, we looked at the momentum, what does it mean, and the basics. So momentum basically tells us about how much motion an object has. So if you have an object that is heavy, it usually has a lot of momentum. That means it has a lot of motion going on. If you have an object that is going fast, that object also has a lot of momentum. So momentum is just another term that we use in order to tell us how much motion that an object has. If an object has a lot of motion, it's harder to stop and it's hard to change its motion. And momentum is equal to mass times velocity. For the second part, we're going to talk about impulse, which is related to momentum, but it's a bit different. And we're going to look at how impulse is connected to Newton's second law. In other words, how impulse is related to forces and how forces can be defined in terms of impulse and also momentum. So there are four objectives for this lesson. You need to be able to define impulse. What does it mean? You need to be able to recall and use the equation for impulse, which is given here. We're going to talk about this later, and I'm going to introduce you this equation later. And you need to be able to define force in terms of its new definition in regards to momentum, which is given here. And I'm going to talk about this again later. And finally, we're going to look at another equation for force, which is given here, and I'll introduce you to it later. When we're talking about impulse or momentum, we are often talking about how things collide with other things. For example, here, this plate, if it hits a concrete floor, it will break, whereas if this plate hits a pillow, a soft pillow, it will not break. So in these two cases, there are collisions, the plates hitting another object, but even though they're the same object, depending on the surface, it has two different results. So why does that happen? Momentum and impulse can explain why the plate breaks. Why is there a large force when the plate hits the concrete floor? And also why there is a small force for the plate that is hitting the pillow. So that is what impulse and momentum can explain when it comes to collision. Before I talk about impulse, I need to show you where impulse comes from. Impulse comes from Newton's second law, and if you remember, Newton's second law states that if you have a mass given by a force, it will accelerate, and this equation perfectly represents Newton's second law. And from this equation, you can see we'll do a bit of maths later to show you how we can get an equation for impulse from Newton's second law, which is an equation of force. And this new equation will tell us about what is impulse and what does it mean. So we're going to start off with this equation of force, but you know that acceleration is equal to v minus u over t, okay? But let's change that a bit. Instead of using v and u, we're going to use final velocity and initial velocity. Let's write down Vf as the final velocity and Vi as the initial velocity. Instead of using u, we'll use Vi. Now we can sub that into this equation here, and then what we'll get is like this. Then we can expand the equation, expand the brackets, so it becomes like this now. And then we can move t to the other side. So let's carry forward t to the other side. And then you have this. Now you will also remember that momentum is equal to m times v. And we have m and v here for the final velocity and m and vi here for the initial velocity. So we can change these two terms here, change it in terms of momentum. So mvf will give us the final momentum, and m times vi will give us the initial momentum. Now at this point, you can see ft is equal to the final momentum minus the initial momentum. When you minus the final momentum and the initial momentum, that just gives you the change in momentum. So ft is equal to delta p, and delta this symbol here is just a mathematical symbol that means is the change of. Okay, in this case, delta P means the change in momentum. So you saw just now from Newton's second law, which is this equation of force, we can get this new equation here, which is expressed in terms of momentum and force and time. So this new equation here is the definition of impulse. You can think of impulse in two ways: F times t, or the change in momentum. So impulse is the effect of a force acting for a given amount of time. When a force is acting on an object for a certain amount of time, we say an impulse has been given to the object, and that has an effect. And what is the effect? It usually causes a change in an object's momentum. When an object's momentum has changed, that means, remember, momentum is basically telling us about the motion of an object. When an object's momentum is changed, that means that the object's motion is also changed. So that could mean that if an object is moving, it's then stopping, or if the object is not moving or at rest, it's starting to move, or if an object is moving in one direction, it changes into a different direction. So those are examples where there is a change in motion and therefore a change in momentum. So impulse is the effect of a force given to an object for a certain amount of time. So whenever an impulse is given to an object, there is a change in momentum happening, there is a change in motion happening. So that is what impulse is. For example, here you can see a picture of a tennis racket hitting the tennis ball. When the tennis racket hits the ball, the tennis racket gives impulse to the ball, and then it will cause a change in momentum in the ball. So the ball will move faster, or the ball changes to a different direction. So that is a good example of impulse in action. Now, like I said, impulse is just another part of Newton's second law. It's related to force, and therefore we can then use the equation that we had just now, which is Ft is equal to the change in momentum. We can just rearrange this equation, move t to the other side, and then we'll get this new equation, and we can use this new equation to calculate force. Just like in this picture here, before you think of force as the product of mass and its acceleration, but now you have a new way of thinking about force in terms of the change in momentum divided by the time. So this is a new equation that you can use to calculate force. So now you have two new equations to remember and to think about: the equation for impulse and also the equation of force. Let's do this work example and see how these two equations can be used. The question reads, you are driving in a car which has a mass of 100 kilograms and is traveling at 8 meters per second. You suddenly lose control and it smashes into a concrete wall. Okay, that's nauzubillah, essentially stopping the momentum of your car in 0.1 second. So there is a change in momentum happening here. What is the momentum of your car at impact? So just as your car hits the concrete wall, we want to calculate its momentum. So momentum is equal to mass times the velocity of the car. The mass is 1000, the velocity is 8, and that will give you a momentum of 8000 kilograms meter per second. And don't forget, because this is a vector, you need to write down the direction. In this case, let's say its direction is forward. Next question. Now that we have the momentum of a car, what is the force required to stop the car? So write out a new equation to answer question B. So we know that force is equal to the change in momentum, delta P, over time, and the change in momentum is basically the final momentum minus the starting momentum over time. So what's the value for time? That is 0.10 second. What's the initial momentum? So the initial momentum is the momentum of the car just before it hits the concrete wall, and that is the momentum that we calculated in question A, which is 8,000. But what's the final momentum of the car? So after the car hits the wall, it then goes to a full stop. The car stopped, and that means it doesn't have any motion, and that means the momentum is 0. Whenever an object is not moving, it has a momentum of 0. So that's the final momentum of the car. So before it has 8,000, but then it hits the wall, and then the momentum becomes 0. So the force exerted by this car is minus 80,000. So you might be wondering, why is there a minus sign there? The minus sign tells us that this force acts in the opposite direction of its initial direction. So if its initial direction is forward, because the force has a minus sign, that means the force is acting in the opposite direction, which is backwards, which makes sense. When the car hits the wall exerts a force opposite to the car in order to stop the car. So to close this lesson, let me summarize the things that we went through. We talked about impulse. What does it mean? Impulse is the effect of a force acting over time. And when you have impulse, what normally happens is that there is a change in momentum of an object. That is also a definition of impulse. And from those two definitions, we know that the equation for impulse is Ft is equal to change in momentum. We didn't talk about it in the lesson, but impulse actually has two units. The first is newtons per second. Can you think of why the unit is newtons per second just by looking at the formula? And also, it has the same unit as momentum, which is kilograms meters per second. And then the other thing that we looked at in this lesson is how impulse is related to Newton's second law, and therefore is related to force. And because of that fact, we can then define force in terms of momentum. And we can write down a new equation for force, which is equal to change in momentum over time. And from this fact here, we can create a new definition of force, and force is defined as the rate of change of momentum. So that's basically saying the change in momentum over time. And that's the end of the lesson. Thank you for watching.